Welcome back, everybody. In this video we're going to continue the crypto map IPsec VPN section by configuring CSR2 and ASA1 to be in a VPN pairing with each other. So in the previous videos we've configured CSR2 and CSR4 and then CSR2 and 5 and 6 to pair with each other. So CSR2 has 3 peers that it's connecting to: CSR4, CSR5, and CSR6. We're going to take this a step further and test out connectivity to ASAV1 now and get all that squared away. So we're just going to add another crypto map entry on CSR2, but we're going to have to go through all the configuration steps on ASA1. So we're going to go ahead and get CSR2 squared away first and then get ASA1 up and running. So CSR2, let's take a look at the crypto config. Should be pretty straightforward from the most part. What we'll have to do is, if we do an access list configuration as well, we're going to go ahead and create IP access list extended ACL underscore, we'll do CSR2 underscore ASA1 VPN traffic. We're going to say permit IP of 10.1.0.0, 0.0.255.255 to 172.31.0.0, 0.0.255.255. And then we will go and create another entry in the crypto map of 40 with IPsec ISAcamp. And we will say set peer to be 11.0.0.11. And then we will say match address of CSR2 ASA1 VPN traffic. And that's pretty much it. We will configure a key here real quick of 11.0.0.11, and that's pretty much all we have to worry about. The next thing we're going to do is configure ASA1 to do all of its configuration. This is going to be a little bit more involved because of the fact of what we have to do. We have to go through the full setup. So we're going to have to go to global config, and we'll do a crypto IKEv1, and we're going to say policy. And the policy number is going to be 10. We have to specify the encryption is going to be triple DES. The authentication is going to be pre-share key. The group will be 5, and the hash will be SHA. That's pretty much everything. Almost everything phase 1. The next step will be the tunnel group. We'll set to say tunnel group, and then the IP address of 21.0.0.2. We'll have to specify the type is going to be IPsec L2L, and then underneath here we'll type in IPsec attributes, and underneath here we'll type in the IKEv1 pre-share key is going to be Cisco, and that's pretty much it. Now we're also going to create an access list. So access list, and we'll specify the name of it is going to be ACL underscore ASA1 to CSR2 VPN traffic. And it's going to be an extended ACL where we are going to permit IP traffic from 172.31.0.0 /16. That's going to be the source of the traffic to a destination of 10.1.0.0 /16 in a subnet mask type of setup. We're going to also now have to create the crypto map where there is no, if we look at the show run all and we do a include crypto, when we look through here, there is no dedicated transform set, right? We're looking through here, we don't see, we see the SA lifetimes and things like that, we don't see a crypto IKev1 transform set, right? So we go in here, we type in crypto IKev1, and then we specify, I'm sorry, crypto IPsec transform set, or I'm sorry, IKev1. Then we specify transform set. If we scroll up a little bit, we don't see crypto IPsec IKev1 anywhere. So we had to go create it first. There is no default transform set deployed. Cisco has done a pretty good job of trying to make things default so that it's almost a no-brainer for people to get this type of stuff to work. That's okay. It works. But in most cases, that's not going to be what you're going to want to run. So we're going to come in here and create the name. It's going to be, we're going to type in IKev1 tset, and I'm going to specify that it's going to be ESP-AES. And if we had not already done the ESP SHA HMAC, we would have to do that. In order for 2 VPN endpoints to connect, one router, one ASA, you have to add this in here, or else it won't work. At least that's my experience with it. So we have that. Now, because of the fact that we have those details in play, the next step in the process that we have to go do is take and enable or configure the crypto map. So we'll type in crypto map, and the name of it's going to be CMAP, and then we have to specify the entry is going to be 10, and then we're going to say match, and we'll specify address, and the address name, we'll have to scroll up here a little bit because the ACL was configured some time ago, which is going to be ACL ASA1 CSR2 via VPN traffic. We're going to type that in. Then we have to hit the up arrow and do set. The peer is going to be, in this case here, 21.0.0.2. Then we're going to have to set it doesn't say it here in the transform set. You have to say IKev1 transform set of IKev1 tset. And at that point, now we're good. If we do a show run crypto, there's a number of configuration pieces that we have in play. Right now we have we've done everything up to this point that we can. We still have to do 2 more. One, we have to type in crypto IKev1. We have to enable it on the outside interface. And then we also have to type in crypto, and then the crypto map CMAP, and we have to specify the interface it's going to be tied to. So interface and then outside. Then and only then does crypto actually get turned on. We don't get a syslog message per se, but if we do a show run for crypto again, you'll see that those commands have been added. We've enabled the crypto map on the outside interface. Then we come down here all the way to the bottom. We can see that we've enabled IKev1 on the outside interface. The last step we have to do in this setup is we have to go in and router EIGRP, and then the autonomous system is going to be 100. And then we're going to specify that the network command of 10.8.11.0/24, and that we're going to say we want to set at the interface level, so interface gig 0/1. We will come in here and we will type in a summary address for EIGRP 100 is going to be a 0.0.0.0, 0.0.0.0, and we're going to send a summary route down to CSR8. We go down to CSR8 and we make sure that our configuration is squared away to that point. And now we're going to create 2 loopbacks. So interface loopback, and it's going to be 172.20, or in this case here it's going to be 31.0. And we'll type in VRF forwarding is going to be S11, and the IP address is going to be 172.31.0.8/24. and then we're going to type in interface loopback 192.168. In this case here, it's going to be 100 will be the interface that we choose, and hit the interface. Then it's going to be VRF forwarding of S11, and then IP address of 192.168.100.8/24. Then we're typing router EIGRP VPN address family IPv4 unicast VRF S11 autonomous system 100, and then we're going to type in network 10.8.11.0 0.0.0.0.255. That should form us an adjacency with the ASA, which we can tell it did right. It doesn't show up in here because we don't have logging turned on, but we did that, and then we're going to type in network of 172.31.0. I'm sorry, 172.31.0.0, and then 192.168.100.0, and be squared away there. So now if we go back over to ASA1 and we show route, we should have a couple of EIGRP routes in the routing table, which we do, and that's a good sign for us. What we're going to be able to do next is go back to let's go back to CSR7, and we're going to go ahead and on the ASA, I'm actually going to come out of here and type in logging enable and logging console debug. So we should see everything coming through. Next thing that I'm going to go do is I'm going to say debug crypto, and we're going to type in IKEv1, and I'm going to set the debug level to 128, and then we're going to specify crypto IPsec to 128 as well. So I'm going to drop out of global config, and then I'm going to go over to CSR7, and I'm going to do a ping to 172.31.0.8, sourcing from loopback 0, and see what happens. Assuming that I've done everything correctly, we should get a bunch of output that goes back and forth. So that seems like it's all good. Undebug all. Now if we scroll back up to the top here, we should see a bunch of data. So I want to focus more on the ASA side of the house now. And let me do config T no logging enable. So let's scoot up to the top here and take a look at what's actually happening. There's going to be a lot of data that's going to end up happening, and we use a pretty strong debug to figure out what's going on here. So we have a inbound UDP connection 30 from CSR2 going to us, and we see that we're going through the IKEv1 messages as we saw in a previous video, where we're focusing on the NAT traversal and stuff like that. We see that the transform number 1 is acceptable in the IKE proposal of entry number 2, and we go through here, we see that everything looks good. We come through a little bit further on down the road, we look at the NAT information and stuff like that, and it says now phase 1 is completed. So that means that we have done everything we need to in order to get the communication back and forth between the devices is good to go. And even in the NAT detection set, it says remote end is not behind a NAT device. This end is not behind a NAT device, so there's no NATing enabled or NAT needed. So we'll be taking a look at that in a different video where we actually take a look at a NATed device. We are finished with phase 1. It says keep alive type for this connection. Dead peer detection is on by default, so we'll have to keep that in mind. Now let's scroll back up a little bit because we need to get back up to the DPD process was right here. So it's just starting the IPsec aspect of it, where we're going back and forth, and we are going to exchange the proxy ACL information. So we're going to say that the remote side is doing a 10.1/16. We're doing a 172.31/16, and everything looks good though. So this is a successful match based off of those details. And then we start moving into the IPsec aspect of things. So we're going to be using Oakley constructing quick mode. So we see Oakley starting to be used. We go back and forth and we start to see the information being generating a quick mode key, and we go back and forth until the VPN information is good to go. Our attributes match the encryption rule, which is good. And then we come down a little bit further and we see that all the information that we need to have in place is working the way that it should be. We just have a lot of information that's going back and forth that we're basically making sure everything lines up, and then we'll be in good shape, and we can see that the data is working as we can see with the outputs. So if we are getting dead period detection is kicking in. If we do a show crypto IKEv1 SA, the SA is up and running, so we know that to be true. That's a good sign. If we do SA and we do a detail, we can see that we're using a pre-shared key and it's main mode and it's activated. Everything's good to go there. We do a show crypto IPsec SA and we look at the details of that. We can see that we have our source and we have our destination traffic that's going back and forth. Very similar output to that of what we saw on the routers. And we can say 4 packets are sent and received. And all that looks good. So we have everything squared away that we need to. If we look at CSR2 and I do a show crypto IKEv1 SA, we have 4 tunnels up and running and everybody is good to go. That, ladies and gentlemen, is how we go through and take a look at all those details. Now, the cool thing about this is, now that we have all these VPN tunnels up between all of the nodes, that's going to give us some flexibility to play around with some other advanced features. We'll be able to play around with some of these capabilities that are a little bit more advanced and take a look at exactly how they come into play. But that's really what we need to be able to understand is what are the details behind the things that we're working with and how do we work with those. So that's pretty much it for the implementation. We've validated that everything's working. Even if I was to pull up Wireshark, you would start to see that a lot of the data coming back and forth. We see identity protection, just like we did in previous videos. One of the main things we're going to see here, this is going to be dead period detection kicking into play. This is going to be DPD, going back and forth. I'm not sure if it's going to show us the flag, but this will be DPD information because that's where it sets up as in phase 1. It's in phase 1. It's an ISACamp message where these are going to be DPD messages back and forth between the nodes, and that's going to be on by default for all of the traffic that we're going to be sending. So that's basically how that would come into play. We can go through the ISACamp process, but basically this is dead period detection kicking into play, and it's very, very obvious that it is. So with that being said, thanks for stopping by, hanging out with me in this video, and until next time, guys, take it easy.